All right, welcome everyone. Today is Wednesday, the 5th of February, 2025, and this is the Cluster API Karpenter Feature Group meeting. We are a sub-project of Kubernetes SIGs, and as such, we follow their meeting guidelines, which basically means please treat everyone as you would expect to be treated, or explicitly so. Please be kind to each other. And if you'd like to talk, raise your hand and I'll call on you. Although there's only four of us, so it's probably not a big deal. Okay, so when last we had met, we Fabrizio had brought up the topic of kind of architecture and some of the architectural questions that we had in the beginning when we started this project. And I think it's probably a good time um, to come back and talk about those things again. Uh, Especially, should I put like VMware by Broadcom here, or what's the official
That's okay.
Okay. Um, so what I'd like to do is I pulled out a couple of the I created this slide deck back when we were originally talking about the architecture. And so what I want to do, and we also have these diagrams as well. So what I'd like to do is walk through the designs that we've talked about to open a discussion into the architecture of how Karpenter works, because I think there are still kind of open questions that we could explore. So I'll walk through the current design of the way that Karpenter works on Cluster API. So the way it works today, and Karpenter has two main um, objects that it wants to know about in order to make something work. There's what's called the node pool and a node class, right? The node pool is a generic definition, and I'll maybe bring up the Karpenter documentation for this because it'll help. Um, so the node pool is an object that helps us describe how Karpenter will create node claims, right? And how it will make nodes in the system. And so in the spec of a node pool, one of the first things you specify is the node class. And this is a concrete type that is different for every provider that you're running Karpenter on. So in this case, what you're seeing here is this is the AWS EC2 node class. And we'll look at that next, but that's how you actually map from what Karpenter wants to like specific instance SKUs in the infrastructure, right? But it also allows you to define things like what taints should be on the node when it comes up, how long it should expire after, if there's a grace period for the node. And then these are the requirements that come out of the node, that come out of the node class, basically. So when a node is created, it would have this instance family label on it. And what this is saying is we only want nodes that could make an M5, M5D, C5, C5D, So when Karpenter tries to predict a node that could come from a node pool, these will be the limitations that it puts on the requirements for those. So you can limit the type of machines that it could get there. And likewise, you can specify the disruption policy for that node pool, meaning how frequently Karpenter should disrupt it. You can define the hard limits for that. And then, the status is filled in by Karpenter. There are other options you can use in the node pool, but a node pool is how you tell Karpenter about, I would like a pool of nodes to conform to a certain behavior. And this is how you do that. Now, the next step is the node class, right? And the node class allows us to get deeper into the details of, how the kubelets should be adjusted for the nodes that are created there. In this case, we're talking about what on AWS, the AMI is the, kind of the image that gets booted. So we have options to specify, what images should be used, kind of subnets. And this will look different for every provider. What we're looking at here is the AWS, EC2 node class, But if we were to look at the Azure version of this, there would be different options in here. So this is very much each implementer can specify this. So the reason that I'm kind of talking about those, and I guess maybe just to complete the discussion, node claims are what Karpenter makes. So whenever it wants to make a node, it will create a node claim to go with it. So you'll be able to inspect the node claim. And this is what Karpenter creates. But the node pools and node classes are kind of where the user comes in. So the way this works for Cluster API today is that user creates a node pool, and the user can create a Cluster API node class. And currently that node class just has a selector in it, a label selector. And what it uses that label selector to do is to list all the machine deployments that are in the system. And if any machine deployments match the label selector that was specified in the node class, then Karpenter considers that machine deployment as a type of machine that can be made, right? And it uses the capacity annotations to do that. So when Karpenter wants to create a new node, meaning Kubernetes has pending pods or unschedulable pods, Karpenter will get the instance types from the Cluster API provider code. And what we do is we list all the machine deployments there using the label selector from the node class. And that becomes the list of machines that Karpenter could make, right? And so we return that as a list of instances, and then Karpenter will choose based on the requirements and what it thinks is best fit for the pods. It will choose to create a node then if it can. And so it creates a node claim object here. And in the logic for the Cluster API provider, we choose, when we see that node claim, we know which machine deployment to choose. And then we increase the replica count on that machine deployment. Now, because Karpenter, in order for Karpenter to be healthy, it wants to see the provider ID in the node claim before it will progress the node claim to a node. So we actually block here and we reconcile on the machine deployments until we see the one that we increase the replicas on, create the machine, and then we add that machine's provider ID to the node claim, and then we create the node claim. And in this manner, this is how we're currently creating nodes using Cluster API with Karpenter. And in reverse, we just decrease the replicas when the node claim is deleted, but we don't necessarily care to reconcile, block on the reconciliation of the delete because, we need to be eventually consistent. We don't need to confirm any details at that time. So I'll pause here for a minute. Are there any questions about kind of the architecture that I've talked about so far?
I like it.
Okay, cool. Thank you, Fabrizio. Okay, so let's talk about another architecture we considered that I think gives us a different way to look at this problem, right? So, we talked about the node pools before, but what if instead of using machine deployments, we allowed the Cluster API node class to instead have a reference to a machine template type, right? So for example, AWS machine templates or something, right? And then some sort of label selector that allows a match to occur. So what happens in this case then is we want to get a list of the machine templates that are created, and we find their capacities from their statuses. So this is like a version of Karpenter without the scalable resource types in the middle. So when Kubernetes has pending pods or unschedulable pods in this case, the Karpenter core will get the instance types from the Cluster API provider, and we just list all the machine templates, and we send them back, and then we filter them based on these labels, based on the label selector that would be here. Then those become the instance types that could be made. And then when Karpenter wants to create a node, we would choose the template of the instance we want to make, and we would create a machine object in the same way that core cluster API does. So we would look at like, we would look at the various configurations, we would put them together with the infrastructure template to make a machine. Now, we didn't go further down this way, but the idea behind this would be that when we make the machine, we get the provider ID right away, and then we put it in the node claim. Now, the owner for this machine at this point would have to be to follow Carpenter's kind of modeling, we would want the owner of the machine to be the node claim or the node pool that it's associated with. But that doesn't really work in the cluster API model because like in cluster API, this should be owned by a machine set or, a machine deployment or something along those lines. So we didn't go deeper into the inspection here, but one of the things we talked about was at the same time that we create a machine, we also create a machine set to own that machine, right? And so really there are no machine sets in the system to begin with. But as Carpenter wants to make nodes, then it will create a machine set to wrap the machine that it just created. So these were kind of some of the ideas that we were talking about in terms of kind of inverting the process, right? So making the machines rather than just adjusting the replica sets. And I think there's a lot to investigate here. And I think, the notion of creating machine sets after the fact is, that's interesting too. And so this though gives us the advantage of the user does not have to create all the machine deployments at like size 0 ahead of time. They just would create all the infrastructure machine templates that they want. And then that would be their inventory basically. So they wouldn't have to create all the machine deployments. The downside is that they don't get any of the nice features that we've put into machine deployments, right? They don't get to use the surge features. They don't get to use, all the stuff, all the configuration options we put in there. So there's like trade-offs, in both directions here. Uh,
May I ask what is a machine template?
I get maybe I'm using the wrong word for that. The infrastructure templates.
Do we need also a bootstrap template just to understand?
Right. I think you would like that you would probably like when I was originally working on this, the idea was that yeah, you might have like an infrastructure template and a bootstrap template here, and that would instruct it how to make the nodes basically.
Okay, so it is a list of pairs of bootstrap and infra basically.
Right, right.
Okay. Uh, one comment. So I see the rationale behind this. Uh, so that let me say, I think that at high level we are discussing two approach. One is have Carpenter to work with a regular cluster API and use all the goodness that is there. The second one is have Carpenter to manage machines, like it does on the other stuff. Let me say on the other, like the other Carpenter provider do.
Right.
Yeah, I think that's the right word.
Yeah.
Okay. And it is let me tell you, it is the Carpenter way. We are making cluster API to work the Carpenter way.
Right.
It is technically possible, and I don't think that you don't even need the machine set. Honestly, I see machines. So in cluster API, you can have standalone machines, and they just work. We don't have much testing for these because no one uses it. But yeah, it should work pretty well. But as you said, I think that's that's the big point. We want to make cluster API to work like Carpenter, or we want to leverage on cluster API strength. Because as a user that I manage 700 clusters and I use Carpenter only on few, I would like to have a dashboard that show me the cluster all the same way. And yeah, I have some machine deployment which are managed by Carpenter and some other that I manage by myself. Mm. So I think that if I take even a further step back, one of the reasons that I assume is behind the success of Cluster API is that it makes all so many different infrastructure incantation of cluster to look all like the same. And I think that's one of the strengths. This is why I like, personally, I like more the first idea, because it is just a regular cluster API cluster. We are just delegating scale up, scale down to Carpenter. This is why I like it, because it looks like everything else. But I understand also, the beauty or the cleanness of the second solution. We
Right.
are we are just using machine, giving Carpenter the way to work machine. Honestly, I don't know if it makes sense to if you probably if you ask to 10 person, they will have 10 different idea. If folks come from Carpenter, they will tell, oh, I like the second one because it looks like everything else Carpenter. If folks come from Cluster API, they will tell, oh, I like the first one because it looks like Cluster API. So ideally, it should support both, but
Yeah.
it comes with a cost.
Right. Well, and
So
no, I think the points you're making are great, Fabrizio. And this is the question, right? Because like talking with the Carpenter developers, especially for the last few years, right? Carpenter and Cluster API they're very similar in many ways, right? Even like at one point, I was talking to Vince about this, and he was like, couldn't we just have Carpenter as a library inside a Cluster API that just, and it's like we almost could, right? Like the the Carpenter users, you're right, they want to see more of a Carpenter experience. And the Cluster API users, they want to see more of a Cluster API experience. And so we're kind of figuring out where that line is. Originally I wanted the more Carpenter kind of experience where it's just making machines. And I do think there's still value to, like you said, maybe supporting both in some way, right? But you convinced me before to kind of like go further into the Cluster API methodology. And I'm actually being sold more on that now because as I talk to users who are trying out the Carpenter Cluster API, one of the things they talk about, so there's one main reason people are going to Carpenter a lot is because it's saving them money in clouds, right? Like when you run it on AWS, it really does do a good job of saving you money, right? And other people are interested in it for like disruption and consolidation and really automated maintenance of their infrastructure, right? Because Carpenter can handle doing upgrades and detecting drift and those kind of things. So when I talk to the users who are interested in Carpenter Cluster API, though, almost all of them say they want the Cluster API interface for exactly the reason you were just saying, Fabrizio. They're like, I'm managing X many hundreds of clouds or clusters. I've got all like thousands of machines I'm looking at, and all the tooling I've created works with Cluster API, and it allows me to like see things in an easy way. And now you want me to run these other clusters in a special way that doesn't have Cluster API, and so I don't have visibility, but I'm saving money, so I guess that's good, right? So like the people who are really interested in saving money, they'll just switch to the concrete versions of these, right? They'll switch to AWS Carpenter or Azure Carpenter, right? Right. But anybody who's coming to this from Cluster API, they want to know how do I put Carpenter on my Cluster API clusters and then also have it save me money, right? And it's like we can do that, but we got more work to get there, right? Right. And so I think it's probably good for us to keep going down the cluster API integration method, right? Making it operate cluster API things, even though it's a little, it feels a little weird from the Carpenter perspective, right?
What if that cluster API was attachable or detachable? That layer with cluster API specifics. You mentioned machine deployment stuff that will be missing, right? But maybe it will be just like, okay, you run this, so it's not necessarily the separate cluster, but it's just another library, which there's class that extends blah blah wherever module. That will be the whole copy machine state architecture, and you just attach or detach it depending on what is the feature flag of copy, for example.
That would be kind of like a support both, kind of direction in my mind. So yeah, it certainly could be done.
Yeah, thinking about that exactly. Cool.
I think that let me say, when you are in front of you an elephant, you have to figure it out how to eat it. And usually it works only one way, one step at a time, one small bite at a time. And I think that those are good architecture. I think that we just have to take. My suggestion is pick one, make one work, and then eventually consider the other one. Just because it takes time to get things to work properly. And so if there is no, you are talking with customer about this, with user about this. And so if it looks like that the first, I appreciate the first one, I explained why. If I imagine this used inside my company or the Kubernetes distribution that we manage, the first question will be, the uh, is customer already have a Kubernetes cluster? They want to use Karpenter on top. They want they don't want to throw away the cluster and create new one. So you always have the brownfield use case, which is often more relevant than the greenfield. So I but you are talking with more people than me about this. So if your feeling is that this is the best choice to tackle us first, let's just write it down why we are doing this now and why we are postponing the other one. The other one is not closing the door; it is there. We can eventually reconsider. But I think that experimenting around these clearly document. Yeah, you can use machine deployment, and you can attach or detach Carpenter to this. Uh, just changing a few labels, and this is good. So you can get the benefit of Carpenter, which are scaling up and scaling down, disruption, etc., etc. You can get all of these. Maybe what you don't get is upgrades because we decided to leave upgrades to cluster API. So there are pro and cons. I think that the key point is we considered, we decided to go to give priority to this one for those reasons. That's it.
Just
Okay.
made me think.
You are the one doing the work, so it is your call.
Sorry, I cut in.
Go ahead,
There.
Pavel.
Just made me think about vanilla cluster API. I mean, and maybe integration with specific cloud. There will be like another API on the way, right? For example, for auto scaling groups.
Well, no, that's the great part. There doesn't need to be, right? That's kind of the
Exactly.
beauty of this,
That's the
right? Like
Carpenter.
cluster API doesn't have to change at all.
And that can be very analogical, yeah. I have the sticker AWS open on my on my laptop, by the way.
So Fabrizio, to what you were saying too, one of the reasons I like continuing to go this direction, because we have it working the way I've described it. Like that architecture is working, people are using it. One of the nice things I like about it is it's very similar to the way that we do things with cluster autoscaler currently, right? Where it's like the user could already have cluster API running and then they could add cluster autoscaler later if they wanted to, right? This works the same way. They could already have cluster API running and then without necessarily needing to change anything, they could add Carpenter on top of it, right? So it's like you're saying, they don't have to throw away all the work they've done already if they're already a cluster API user and they're enjoying that. So that's another reason why I kind of like continuing to go this way, because it's like users would expect this experience. All right. Well,
The templates were mentioned, and I really like this template thing. If only all cloud providers agree, right? I guess.
Well, that's already a part of the cluster API contract, right? Like I misnamed them, but what I'm talking about is the infrastructure template, right? So we do have, this is like the node class in in Karpenter, right? The node class is different for every provider, just like for us, the infrastructure machine would be different for every provider, right? Like a Docker machine is different than a kubemart machine, right? So same kind of relationship there.
Yeah.
Okay.
Okay. Oh, go
Sorry,
ahead.
folks. I really have to drop because I have to eat something and I have another meeting in a
No,
few
for sure,
minutes.
for sure. Yeah, we're running out
Uh,
of time anyway. So Fabrizio,
and
thank you for hanging out extra late. Pavel, thanks for staying up
mm,
too. Like appreciate all the people here. Marco, you're kind of close to my time zone, so like, you could go back to work. Anyways,
thank
see
you.
you all
Bye
next time.
bye.
Thank you, everybody.
Yeah, folks.